Okay, good afternoon, everybody. Sorry for this 15 minutes delayed. So I think we're going to start right away. We are in this topic, Smart Mobility Solutions, number one. I am the moderator, Francesc Robusté. I am a professor of transportation at Barcelona Tech, the Technical University of Catalonia in Barcelona. And I'm going to introduce the speakers. We have five well-known speakers. They're going to talk about a number of issues regarding smart mobility. And I'm going to introduce them when it's their turn to speak. But let me tell you a couple of comments before. I always like to put in the balance between the chemistry or even alchemy of data sensors tracking, that this is the main... Louder? Okay, I'm sorry. I was saying that I like to put this on one side, the chemistry or almost even alchemy of data sensors and tracking, that this is what we're here about, versus the physics, economics, and psychology of mobility, when we talk about mobility. Because we're going to talk about people, companies, and they have a lot to do with physics, economics, and psychology. I like to think of the city as a mobility factory, producing factory, and also the mobility users are customers, smart customers, but they have their own behavior and they have their own perceptions. Sometimes, to us, they may not seem that they are very logical. When we talk about mobility, we talk about how to overcome distance and time with the help of information, of course, for people and goods. But we talk about processes that are dynamic processes. And of course, ICT can help a lot about having information and making the right decisions. But is just information being smart? Is chip sensors, GPS, is that intelligence? To me, we can be intelligent. Actually, I think we have been so far in the last decades or even centuries. We can be intelligent. We have been without too much technology. Now we have much more technology. We need to prove that we are also intelligent. The intelligent transport system is the useful, in a cost-effective way, technology. In a cost, I put cost between quotation marks, I'm sorry, because we should talk about social cost, ecological cost, depending on our goals. No? And finally, I think in mobility, especially mobility, I always like to draw a triangle with administration, any kind of administrations, local, regional, state, country administrations, companies, operators, and then research centers, universities. And in between, in the center of everything, the user of the mobility system. No? Okay, let's quit this small introduction, and then we're going to start with our first speaker, Dr. Chris Baroni-Bird. He is the Vice President of Strategic Development at Qualcomm Incorporated, and he's going to talk about enabling connected and electric vehicles. Whenever you want, Chris, you have the floor.
Thank you, Francesc. Can everybody hear me okay? Okay, great. So as Francesc said, my presentation today is about a couple of technologies we're developing at Qualcomm that we believe will enable and accelerate the commercialization of connected and electric vehicles. And my emphasis today is really around the intersection of these with the smart cities focus. So many of you may know that Qualcomm is a connectivity-based company. We're big in the smartphone space and tablet space, and the connected vehicle offers a lot of opportunities in this area. But what I want to talk today is more focused around the smart city aspects. So I'm interested in safety. How can we improve road safety using wireless communications? And how can we improve the energy and the environmental performance of the city through wireless electric vehicle charging, which we think will help to accelerate the commercialization of electric vehicles and the attractiveness of electric vehicles. We believe that the future of transportation is increasingly going to be electric and wireless. To talk about and now power transfer. As many of you know, road safety is still a challenge, even though vehicles are getting safer every year. And a lot of the fatalities that occur on the roads worldwide are actually vulnerable road users, such as pedestrians and cyclists and people on a motorbike, for example. As you can see, more than half of the people in the world who are killed on the roads are actually outside of the vehicle or outside of the automobile. And we know from probably many of you may know that pedestrians are far more likely to be hurt in an accident than the driver of the car, and that a lot of the causes of these accidents is caused by the driver not paying attention a few seconds prior to the collision. So we were thinking, how could we help improve that to reduce the fatalities? And one area that we think is very attractive is vehicle-to-pedestrian communications, which we think can complement the sensing technology that will be on vehicles increasingly to improve collision avoidance. And we demonstrated a prototype and recently demonstrated it with Honda, who we collaborated with on this, to demonstrate vehicle-to-pedestrian communications using a smartphone as the pedestrian's carrying device, because many people are carrying a smartphone who are walking in a city. They may even be distracted as they cross the road. And this technology, we feel, has the potential to improve safety both for the pedestrian as well as for the driver of the car. I'd like to show you a short video. It's a couple of minutes long, which better explains this.
Demonstrates several scenarios, including line of sight / crossing path, non-line of sight, and backup scenarios. In this case, the pedestrian is in direct line of sight of the driver of the vehicle. The pedestrian is initially standing at the side of the road and then starts walking toward the intersection. The vehicle also approaches the intersection at a normal speed. When the range and trajectory fall into the scope of the warning algorithm, a warning will be displayed in the heads-up display of the Honda vehicle, which in this case is an Acura TL. A similar warning will also be displayed on the smartphone carried by the pedestrian. The phone is initially in a standby mode when the pedestrian is indoors or stationary for a period of time. But when he starts moving and goes outdoors, the DSRC modules are fully activated. This functionality reduces the power consumption of the smartphone when using the DSRC modules. Next, when the pedestrian starts walking, the smartphone sends and receives DSRC messages to and from the Honda vehicle. In addition to the contents of the basic safety message, the vehicle can also receive information about the pedestrian, such as whether the pedestrian is texting, listening to music, or on a phone call. In this scenario, we'll show the warnings to both the driver and the pedestrian when the pedestrian is actually obstructed from the view of the driver by something like a parked vehicle. The key takeaway here is that even though the pedestrian is not directly visible to the driver, warnings are going to be generated in both the phone and in the vehicle. The pedestrian is initially behind two parked vehicles and starts walking toward an intersection, while a vehicle is also approaching the intersection, moving at a normal speed. Again, the safety algorithms will generate a warning if the trajectory and the range fall within the scope of the algorithm. Here, we are demonstrating that warnings can be generated in the vehicle and the smartphone when a vehicle is backing up in the presence of a pedestrian. In this case, the audio warning on the driver's side is going to be a tone that is increasing in frequency as the vehicle approaches the pedestrian. On the smartphone side, the warning is a series of beeps that are similar to the backup alarm that is common on commercial vehicles.
Okay. Now, it's a very intriguing idea, and we think it holds a lot of promise, but there are still some technical challenges that need to be addressed. In the interests of time, I'll move on to the wireless power section of my presentation. And I don't think I need to tell you about some of these statistics, but we see that air pollution continues to be a challenge or a problem in many major cities around the world, and has associated health impacts with it. There's also energy and environmental global climate change issues as well associated with mobility. So we feel that the introduction of electric vehicles is going to help significantly in terms of the energy and environmental issues, especially as more and more vehicles are introduced into the marketplace. I'd like to show you a short overview of our wireless charging technology. We have wireless charging for smartphones, but I'm going to focus here on wireless charging for electric vehicles.
The future of electric vehicles is exciting. And how electric vehicles are charged in the future will be key to their success and growth. With stationary wireless electric vehicle charging, you simply park as you would normally and charge up. Once parked in a charging bay, charging is initiated and power is transferred wirelessly from a ground-based charging pad to a similar pad on the electric vehicle. Wireless charging involves no cables, so there's no need to plug in, no fuss, just wireless. With Qualcomm Halo technology, a high degree of misalignment tolerance means there is no need to park precisely. Just roughly position the car over the pad and start charging. Wireless electric vehicle charging offers very efficient high energy transfer, which is not affected by adverse weather such as rain or snow. Wireless electric vehicle charging makes charging convenient. You don't have to change your routine. Simply top up while you're at work, at the supermarket, or picking up the kids from school. And when you get home, you simply leave your electric vehicle to charge. Qualcomm Halo, we're also working to take wireless electric vehicle charging to the next level. Dynamic charging means your vehicle could be charged wirelessly while in motion. This means that in the future we could see vehicles with smaller batteries in lighter and cheaper cars driving long-distance journeys with potentially unlimited range. Imagine wireless electric vehicle charging being as easy and as widespread as Wi-Fi is today. At Qualcomm Halo, we believe that the electric vehicle industry needs to work towards a single open standard for wireless electric vehicle charging, so the mass adoption and acceptance of electric vehicles becomes an everyday reality.
So as the video basically indicates, we see wireless charging as being very attractive in the near term, the mid-term, and the long term. In the near term, because of the comfort and the convenience features associated with not having to plug in. In the mid-term, in terms of things like semi-dynamic charging and public place charging, the increased attractiveness of the city layout if you don't have all these cables lying around. And again, for applications like taxis and perhaps buses at intersections, putting wireless charging could help reduce the size of the battery. And then longer term, as we think about deployment of this over highways and on major arterials in cities, we see the real potential to reduce the size of the battery and take the cost of electric vehicles down. there are many criteria that need to be addressed when we tackle and commercialize wireless charging and work with our licensees. One of the key ones is making sure there are standards in place that allow interoperability, especially for public parking. And we're very pleased that recently there was an announcement from SAE, the Society of Automotive Engineers, to create a standard around 85 kilohertz operating frequency for wireless charging, which is a frequency that we've been advocating for a while. We think that this type of standard is going to be essential, especially as we get to public parking, to allow interoperable between vehicles and charging pads. So in summary, the urban centers, cities in the future will need to meet these criteria or have these needs for future mobility. And we think the solution to these needs is really around accelerating the adoption and commercialization of electric drive vehicles, preferably battery electric vehicles for city driving in particular. The introduction of increasingly connected vehicles, connected to each other and connected to the infrastructure as well as to the cloud, and capable of autonomous operation, especially when connectivity is combined with sensing technologies, which is increasingly the case in the vehicle. And Qualcomm is at the forefront of developing many of these enabling technologies. So thank you for your attention.
If you agree, we're gonna, at the end, we're gonna have some time to ask questions to all the speakers together. Otherwise, we're gonna be delayed for sure. No? So let's go on with the second speaker, Gianluigi Fiorucci. He's president of SUD, and also is very active in a consortium, a group of companies called Think Global. Companies providing smart city solutions. He's going to talk about Move Smart. It's an award-winning project here at this Congress, Smart Cities Congress, 2 years ago, I recall. And he's mixing traffic data with real-time traffic, connecting with parking facilities and also public transport with transit. Whenever you want, Jean-Louis.
Thank you, Francesc. Good afternoon, everybody. As Francesc said, 2 years ago, we won an award as a best project for Smart City. It was a project made by Semiax in Nice to develop a solution around smart parking, but more global than just smart parking. Today, I would like to present 2 years after where we are, what is our vision. And to start, to illustrate the project, I would like to show you a quick video to present the different concepts and what is our vision on smart mobility. Okay, I hope you enjoy the video. Basically, the starting point of the project was smart parking, but we consider the mobility is a global ecosystem on a city, including traffic, parking, of course, and transportation. Smart parking is a really good starting point because we have, I will explain you later on, a good business model around it. But it's very important to have a transversal approach, including these three components. You know, it's important because one of the main problems cities are facing is traffic congestion. It's pollution because of traffic. It's also re-energizing the city center. And what is important is to be able to control in a better way the flow of cars, control the stock of parking, and of course using massively the public transportation or alternative transportation service like bicycle service or electric car services. What we are trying to do in our project is really to be able to combine all this information to provide the information to the city agents and also for the citizen to make the better strategy on their move inside the city. Currently, we are really citizen-centric. We are trying to provide them the maximum of information in real time through a smartphone application. And for us, what is important is to help them also to make the choice not using the car from a point E from their departure to destination. And that's the reason we are working also with public transportation. We connect also the service for electric cars, bicycle service. And smart parking has a very important impact as well because by deploying all the sensors, we know exactly the level of occupancy of the street. We connect the parking garage as well, and we are able to know an estimated time to park your car when you arrive at destination. And one of the strategies we want to put in place is to provide this information for multimodal itinerary calculation service. Like that, maybe the last kilometers, instead of going inside the city, we are able to park outside and take the tram or take a bus or other way of coming inside the city center. Other mechanism we can develop as well is dynamic pricing. Be able to change the price of parking by using the traffic information. If the city is very congested, increase the price of parking, reducing the price of public transportation, even for pollution. In some countries also it's based on level of occupancy as well. It's probably not very popular everywhere to use this approach. But basically it's to be able to combine all this information in real time and to create scenarios inside the city. Of course, to make it happen, we need to interconnect everything because we have to provide one application where users can make their own choice. At the beginning, Frances was saying we have good technology, we have to help people to be more smart. We need to provide the information, and what is important is to have one solution integrating the different services. Other very important aspect about the congestion is a lot of cars are staying for a long time, more than was supposedly be. We also need to re-energize city center in terms of retail and shopping. So that's the reason in Nice we are starting. This product will be released soon. It's on test now. We create a service called Close to Me in partnership with a company working of making contents and point of interest to be able to re-energize the shop by making coupons, smart deals, but also to be able to have tips about the city, trying to inform people about what's happening inside the city. One of the important aspects of all these kind of service is to create a more healthy environment for people, because if we reduce traffic, we are able to also reduce the pollution. And of course, we can save time and reduce stress. But in parallel of the benefits for the citizen, we also have benefits for cities. Of course, the first goal is to reduce congestion, pollution. But by using smart parking, we can also increase the revenue because country to country, the numbers are different, but the fraud is one of the problems on street parking. And basically, by having the sensor, we are able to control what the payment level is and making enforcement. Also, by using this new technology of sensors, we are able also to optimize costs. We're also creating a lot of new service because the technology we are using to merge and all this real data in real time is really helping to build new and innovative services. If I would like to show you again the video like that. After my quick explanation, you probably see it in a different way. Just to finish, a demonstration is available on the booth of ThinkGlobal E516. Thank you.
Thank you very much, Jean-Louis. Now the third speaker is Maria Serrano. She's the director of Smart City Excellence Center at Telven, Schneider Electric. She's a telecommunications engineer, and she's going to talk about a very attractive title, Smart Mobility for a Sustainable World. Whatever you want, Maria.
Good morning. Thank you for attending this panel. First of all, I would like to introduce our company. This is the compulsory corporate slide. We are a 24 billion euros company with more than 40% of our sales in new economies. We serve customers in the 5 key segments that we see here: utilities and infrastructure, industrial and machines, data centers, buildings, and residential. And we also deploy successful projects all over the world, dedicating over 4% of our sales incomes to research and development projects. This is our view, our vision, what smart city means for us. For us, smart city means smarter, efficient, and livable. I'm not going to bore you about the details of that, because I think it's the type of message that we are always talking since the last 2 years. But I would like to focus these challenges on the mobility segment. In this case, to be efficient, sustainable, and livable has have a special impact on a huge number of citizens and companies moving inside the cities and accessing to the cities, commuting every day. So we have a lot of solutions in the different aspects of improving the mobility in a city, but I'm not going to bore you also explaining all the portfolio of solutions of Schneider Electric for smart mobility. Instead of that, I would like to share with you two of the customers' cases we have deployed in the last 2 years. First of all, Dallas. Dallas, we helped the city to understand, no, the city helped us to understand which challenges they need, which were their goals. They needed to focus and to improve mobility and pollution in one highway that is shared, the maintenance and the operation with another agency. We provide to them the solution for traffic management, and this solution has two main features that I would like to point out. The first one is the decision support system that allows the city agents to simulate scenarios of possible events or incidents and propose different action plans, simulate them, and when the event happens, take the best solution, the best action plan, and share all the action with the rest of agencies implied in the maintenance. This solution, I'm sorry, I passed away, very happy, very fast. The second is second capability or feature that we have to point out is the multi-agency coordination, okay? So Quito in Ecuador is a very different city from Dallas, but we also try to understand their objectives. In this case, their goals were to reduce congestion, for sure, but also they needed to serve the demand of the citizens to have better information for an intelligent planning of their mobility. So we provide to them a solution, an integrated city management platform with real-time adaptive traffic management system, with travel multimodal information system, and it's just operating since a few months ago, and we expect a 17% time reduction of movements of vehicles and a very important reduction of pollution. I would like to point out also that we have provided for them an application for citizens to decide which route to take anytime, with real-time information. Sorry. But I would like also to share with you some future trends that we are just now in our research and development centers, we are just considering. The first trend will be the cooperative mobility. When we talk about cooperative mobility, oops, sorry. Yeah, okay. We have seen from Qualcomm some applications that are able to connect vehicles with people, for example, car with other cars, but also we think that it's needed to connect vehicles with infrastructure. So if the city already have an integrated database with all the information, it's really easy to construct, to build this connection between the cars and infrastructure. The second trend is that we are already seeing also in the previous presentations is the smart urban furniture, adaptive, sensing, responsive, and interactive with the smartphones, because we believe that the smartphone is the driver to connect to all these new infrastructures in the city. And also new models of ticketing through NFC and integrated travel card for citizens and so on. And the third, and for me the most important trend, is the smart mobility becoming more social. This slide is from last week. TrendsMap is an application in the web that is tracking Twitter to identify the most important trends, hashtags in the web, in the network. This one was when the Typhoon Yolanda was happening, and from this information, they published some hashtags, vital hashtags, in order to be able to focus the rescue emergency people and to crowdsourcing the resources to everyone to know where to address for assistance. Why, if we could do the same with other hashtags or information moving in the social networks, and we could have an app in our smartphone that maybe wake up 20 minutes earlier in the morning because there is an accident in our usual route, and it's able to propose us an alternative route, for example, in public transportation, knowing that we have, for example, 3 children and we need time enough to arrive on time to the school. So this is possible if we are able to connect all this information in a database integrated solution like ours. So what we will see. Today's mobility is focused on supplying, on the capacity of the roads, on the streets, and it's vehicle-oriented. It's focused on reacting to the events and incidents that are happening, and is obsessive on knowing and seeing what is happening. We need to know what is happening, and we are obsessive on that. And we spend a lot of money on physical infrastructure. Future mobility, smart mobility, should maximize efficiency, resilience, and sweating of assets, should be oriented to people, customer-centric, not to infrastructure, should be focused on positive business models with outcomes. Better predicting and anticipating in order to avoid is really important. Imagine if you have an app that could send you a message and say, you don't know, but tomorrow the pollution will be so high and you are asthmatic people, please take care. We need to be able to give this kind of solutions, and also the investment should be focused on data fusion, predictive analytics, integration, decision support systems, and adaptive tools. And all of this, we are sure that is not we are not able to achieve these goals, a company on its own or a city on its own. We need to collaborate, and we need to collaborate with best-in-class global and local partners. We think Smart Cities is an exciting place for innovation, and we know that our collaborative model with best-in-class players like Cisco, like Microsoft, and also with local players to understand the needs of each city is one of the key issues for achieving these goals. So thank you very much.
Thank you very much, Maria, and especially thank you because there's 20 seconds left. That I'm going to make this joke that, you know, when there is an accident and we get to work or the school late, we just say, I'm sorry, there was an accident, I'm sorry I'm late. But it's better if we have all the information, yeah. And then we can decide what we do, no, with our time. Okay, the fourth speaker is André Martín Díaz. He holds a master in aerospace engineering from the Instituto Superior Técnico of Lisbon, and also from Superaero in Toulouse. He's the head of intelligent systems at SAIA, and he's going to talk about MobiMe. It's a project, a mobility management engine for services integration in the city. Whenever you want, Andre.
Thank you very much, Francesc. Welcome, everyone. So, I come from Portugal. I come from a small, yet almost more than 200 people, engineers, working around the fields of mobility, aeronautics, and right now with a strong focus on smart cities. I'm head of intelligent systems there. I also coordinate what we call the Smart Connected City Center, the S3C. and I'm going to be telling you about what kind of projects were involved and what are the capabilities of our platform and how we've been using it. So of course we're all around here around the subjects of smart cities, and smart cities for us, as for most of the people around here, it's all about integration, sustainability and connectivity, and we believe that integrating this all around the world and all around the different cities into single platforms, into single architectures where you can integrate all the different platforms is the way to go. We at SEIA, we started with mobility, and this is more or less the field that I'm going to show you. So we deal with subjects like smart grids, smart mobility, integrating information from devices, sensors, different sources of information, third-party suppliers of information. We talk about sustainability, so assessing economic impacts, the social impacts, the environmental impacts of the mobility services that we are offering. Some of the projects that we're involved with focus more on environment, others focus on social. For instance, I would invite you to see our project Marianas that we're starting with the city of Rio de Janeiro, where it's a collaborative project with a favela, with the biggest favela in Rio, exactly to deploy a smart mobility solution with a very strong social implications for the city. And of course, and this is my part in the business, it's all about connectivity. So getting all these different components of the cities that we live in, either static components, transportation infrastructure, all the smart devices that are all around us, and getting all the information up to the cloud and making some sense out of it. But in the end, what we want to be doing with all this information and around the subject of mobility for us is really focusing on the individual. So independently of where he lives or where he travels to or what services he uses, he wants to have what we call a single mobility invoice. So he should be able to really assess and hopefully in real time what is the true impact, not just financially or economically or at a more global level of his choices, but also like the smaller scale impact of how his choices affect the city metabolism. So it's all about connecting vehicles, shared mobility services, public transportation, infrastructure and energy services through dynamic tariffs that can be built into one single invoice. So our platform, what it attempts to achieve is this vision, and we're slowly, step by step, doing this in different cities across Portugal, and now also focusing on Brazil and hopefully other countries around the world. So what does our platform do? What does our platform do? Basically, it's a roaming by design platform which integrates different operators, meaning all those guys that invest in infrastructure and want to offer some service through the existing infrastructure, be there cars, bike sharing systems, smart parking systems, EV charging operators, public transportation, and all those guys that have users who want to offer and deliver some services. So we provide a neutral platform where multiple operators can offer multiple services and define their own business models accordingly. So you can choose, if you are offering some kinds of services to your end users, you can choose whichever of the available operators. You can make agreements, and we manage all the B2B relationship between them. Of course, we have to focus on security, on common authentication mechanisms, on on ensuring the correct contract management and neutrality for our platform. So in order to do this, we have developed our expertise around operations management for all these different kinds of services, on the construction and operation on the platform itself, and of course, on knowing and building the devices that people actually interact with. So we embed intelligence onto bicycles, onto cars, onto charging stations, onto any kind of available sensor, and then we make sure that that information that is business and technically sound gets back to the cloud and can then generate new mobility services that you haven't even thought about. So how do we do that? So we provide an architecture for services integration in the city. Basically, we've developed a layer where you can connect to any kind of generic device to our backend platform, which then provides different kinds of services, technical, CRM, billing, asset management, device management. But of course, this is all modular. The idea here is making sure that in a given city, all the different services that, for instance, some of them lack a business layer, some of them focus more on the technical side. They get to be integrated and then communicated to the end user on the upper layer through a portal or any kind of smartphone-based applications. And of course, we have to interact with other given available services in your city. So I just put out some of those. I'm going to be talking, for instance, about the case for EV vehicles and how we interact with them. But basically, for that, we have three different modules, which we call the Smart Device Cloud, the Smart Business and Services Cloud, and our WISE BI Analytics platform, which can then do a lot of work on the information on the services that we provide. One of the interesting projects that we're involved in, it's about roaming of services across Europe, focusing initially on e-mobility, but also, for instance, through this project, and we're just initializing our testing, real-life testing, you might be able to go from Portugal and then to Spain and pick up your car sharing, a car for car sharing just with your smartphone application that we provide in Portugal. So it's really all about integrating different services existing all over Europe and getting them to communicate with each other and making sure that the user can always use the services that are available to him. Concerning electric vehicles, for instance, we have real-time integration with different manufacturers, such as Renault or BMW, where we provide not only just dynamic availability information, but also, for instance, the possibility to reserve charging stations, to do smart charging. But what is very interesting is that OEMs are now turning towards what they called mobility providers, mobility solution providers. So like a BMW or Renault can come to Portugal or any country where we are, and they can just easily integrate with those last mile or those within the city movements like car sharing or bike sharing applications, and that turning into a really integrated view for mobility. What else can we do? We can do ranking of the different cities. So right now we have like 40 different cities on our platform with different kinds of services, different kinds of metrics, different operators as well. We can do ranking onto different kinds of metrics. We have grid integration in real time, so we get to assess the real impact of the movements in terms of the electricity sector. You get to know how people are using the different kinds of services. Here is an example for electric bike sharing. You get to know how users are really using the infrastructure and the different kinds of services. So here you can see at the global level, in terms of Portugal, you can see the houses over there, you can see different services available, or you can see them in an ever more microscopic scale. Of course, you can also do usage profiling and take a look at when people are really using the services during the day. Some are more seasonal over the year, some are really daily, and they depend on the place where you have installed them. So I've read this one. So just to wrap it up, in the end, what we provide is a roadmap for services integration into the smart city, coming from the user on what he can do, like with this app, but it really only what we have to make sure with is that all the different platforms that interact in the smart city world are connected to each other, independently of how the user interacts with them. It's really, the important thing is that you can then get access to the EV charging network, to the public transportation network, to the parking meters, to the metro, to the subway, and then getting a feedback on how he's using it and how we can improve his mobility. Okay, thank you very much.
Thank you, Andre. And our last speaker is José Antonio López Becerra. José Antonio is well known because last year also he was the speaker representing his company Saba. He's a CTO of Saba Infrastructures. Saba means Parking Facilities of Barcelona. It's a private company. They are well spread internationally. He holds a PhD in computer science and also an MBA in ISD Chicago School and another ISE Management School in Barcelona. José Antonio is going to talk about his company, of course, Saba, car parks serving urban mobility. whenever you want, Jose Antonio.
Thank you. Thank you very much for all of us, and thank you for staying at the end of the session. I know you may be hungry and tired, so I'm trying to share with you some experiences, real examples. So what we're trying to do is showing real examples that these near future examples and experiences that all this Congress is all about can be applied today in an environment, let's say quite common environment in quite old business sector, which is car parks. So first of all, who we are an international car park company and also logistics, big logistics area in 6 countries. You have your figures here. So let's just start for 2 examples. That's one. My first part of the presentation is 2 examples. Last year here, as Francesc mentioned, we present our most innovative technology project during 2013, this year, and this is how it works.
Saba Parkings is the first company to offer its customers an innovative access and payment system through the OBE onboard equipment electronic device. This device is known in Spain as the Via D, Telepass in Italy, Via Verde in Portugal, or Autopasse in Chile, and it's the same as the currently used on all the highways. To access a parking, the device installed on the customer's vehicle sends out a signal that records the time of entry and the barrier opens automatically. At the exit, the system instantly calculates the time and value of the stay through electronic control and sends the charge directly to the customer's financial entity or to the corresponding authorization center. Thanks to the OBE electronic device, the customer does not need to collect a ticket or stop by the ATM or validate the ticket at the exit point, nor keep all receipts. The customer can control the payments more comfortably by receiving the invoices via email by subscribing to the e-receipt service on the website www.saba.es. Smoother flow and less access time. No need to lower the window. Skipping the waiting queue at the ATM and payment security. More convenience and sustainable. By using OBE, Saba takes a step forward in urban mobility management.
Okay, so this today is working. What we have done here is quite simple. We use an existing technology, which is this one. It's a small device used in the highways and designed for non-stopping in toll highways, and apply this to the car park environment. The result is that you've seen before, and this is our experience here in surrounding Barcelona. This is how it was 3 years ago, when we started this project. We have a small implementation of this device running around in Barcelona. This is more or less the payment methods that people uses in 2010. Today, the number of customers that uses this device has increased significant to 30% of our customers, which means in 10 months, more than 1 million 1 million cars using this technology. And at the end, this is technologies. It's something that it's not new for us, but what is new is that the customer satisfaction has increased a lot. So this solution, it's so well received in the users that now it's in the top 3 most valuable services that we have in our car parks. So let's say the usefulness, this solution is explained here. So it's very smooth flow at the entrance, which allow traffic jams normally in peak hours. And the bigger car parks, there are no tickets, there are no waste of time going to the cash machine, and you can bypass the payment. But at the end, this is just a starting. That's for the very beginning. This is, let's say, it's new in Spain. It wasn't new in Portugal. We have a previous experience before, but what's new here is that we use this device for much more than payment, which is this defined at the very beginning for this. And which is the next step? It is the car identification. We have mentioned before many ideas about car ID, so this device can be done. That we can know the model, license plate, CO category, size, if they have insurance or not. There's a lot of information that can also be get from the license plate, but also stored here in this device. So can we do with this information? We can charge using this car identification, for example, if it's an electric vehicle, or if it's a CO, a higher emission car, or if, for example, some variables that we mentioned before in needs, for example, I mentioned before, if there's higher CO levels, we increase the taxes depending on the car. And also, it offers a new payment formulas where we can offer much more combinations and solutions for our customers. This is the first step of the project, and we are facing lots of opportunities during the next 2 years. Now I'm trying to share the second example, which is what can we do over these existing technologies, electronic products. So many people know that when you go to a restaurant or a shopping mall, these kind of things, stores offers you discounts or royalty discounts. What we have done on this technology is define an electronic product. I have one here. It's a page that you can print by yourself. So what that works, what do you do is use your mobile, download our app or whatever app that can connect to ours, and you can just scan the QR code, and afterwards you get the discount in your, or whatever discount it's behind that code, in your car park use. Even on street, which is then our next step for this. So the app can be done through ours. We have one of them, of course, but we also can offer that the code that goes behind the app can be run in whatever app you like. And behind that, there's a commercial use that we may found useful for professionals, which is what happened with my receipt. Do I have to wait for my highway invoice or to my bank invoice? It's not needed. We can send you an invoice through email with the exact detail of the car use or the discount applied to your car park use. Again, this is the second example, so I think it's very interesting to explain you the very well reception that we have had here. Today we have 26 car parks using this technology all around Spain. At the end of the year, we have all of our car parks in Santiago, Chile, and we will also moving forward the Portuguese solution, and next year all the Italian car parks again with the same solution, just the same solution everywhere. What we have planned to do for the next 2 years, over again this kind of solution. So things like examples that have been explained before here. If there's a space available, can you pre-book? Can you buy by yourself through internet or through the app some kind of discounts or product if you have a frequent user? Well, you can, as a commercial offer, like a shopping mall, you can buy yourself, get all the discount from out and offer to your customer through your, for example, the bill that you get on the TPV, on the on the Decathlon, on the FNAC store. So you use just the same solution, but with the brand of the commercial store. And also we can offer cross-selling. So you get the ticket of the theater, for example, or cinema, and you get also at the same time the car park space for you. And last but not least, which is very interesting for us, is that we can link the car park use with loyalty card, for example, frequent flight users or shopping malls loyalty card we are very used in car parks. We have also environmental examples, and I'm going to move on, and we don't want to spend more time. We have plenty of much more technology, but it's interesting to know that we have even plugs for electric motorcycles, which is in South Europe is very lot of use. We have remote control center here, and behind of this technology, of course, it's cloud services management that we offer to the city. Just 30 seconds for two near future example, which again over infrastructure in city centers, in car parks, which is self-storage solutions. All cities have a huge problem in small storage. There are not like the new one, like the American ones, is really interesting there. But in Europe, it's not easy to find space to store, say, those things, keys, and whatever you don't use frequently. Well, we want to bring in our car park facilities small stores, self-storage, where you can park your car and store what you like just behind your car. And the last one is logistics. Logistics came from our logistics brand and logistics branch. As what happened to the new business e-commerce that is increasing very high. Is how we can deliver those goods to the end user. It's very difficult to reach the end user through classical shipping. So what we have defined here is different combination of picking areas where you can get your good bought by e-commerce channels. And all of that, it's done through a working business model. So behind this, what we can do is support all the investment and the infrastructure that is behind, which is really difficult when we talk about the smart cities, because at the end it costs money and it takes lots of time to find the investment to do that. So you know what to do. We have a ruling and a working model running in our company. Thank you much.